welcome aboard our Pacific Seacraft Orion 27 built in 1979. Though she's 27 feet long and 9 feet 3 inches wide, the traditional head that was on here I felt took up way too much space. So I looked into composting or desiccating toilets. And the other advantage besides space with a composting toilet is their simplicity. I don't have to be concerned with them plugging up as a traditional toilet may at times, and then get stinky over time due to the gases permeating through the plumbing and the tanks. And finally, there's the need to go find a pump out. But I checked into Airhead, Nature's Head, and Sea Head and found they also took up more space than I wanted to give up. So I went the DIY route, and that's what this video is about. So let's go below and see what we have. Watch your step here. Got a number of projects going on. One with the engine and plumbing, and you know how it is. Project A is held up by Project B because of parts for Project C, and well, I think I'm working on Z. Anyway, take a left over here, and that's where the head is. The view on here is a little distorted because of the wide-angle lens I have on. But these are the constraints I had for this toilet. That seat is, the shower seat is 14 3/4 roughly off the floor, which the composting head sits. So that was one constraint, and no commercially available toilet would allow me to, with that little space, to install one. And then I also needed to have enough room for my feet. There's not a lot of floor space, so I had to raise the urine receiver on here. As you can see, floor space is pretty small in this little head. It's a 27-foot boat. Anyway, I have about 22 inches of lateral direction and about 16 inches in depth. So as far as components go for this system, this is a 12-inch right off the shelf Beavis toilet seat. I installed this rubber gasket from McAster car, very soft hollow foam that sits on the seat to make a sort of an airtight seal. Under that, I just have a regular seat which meets this 11-inch diameter U.S. plastics bucket made of LL linear low density polyethylene. I like this material because it's easy to form and easy to weld. We'll get into that later. Below this is a urine diverter which I bought from Johnny Compost as part of a Johnny Compost system. Not terribly happy with how much this stuff costs, but it's what I found convenient to have here. Included is this little bump out which is an air intake, and it has a screen in here to keep insects from getting into this system. And then below that is the catchment for the urine, and this is just a repurposed soft soap bottle. And I have a, I think it's 5/8 thin wall silicone tube for collecting that. The handle I built myself. This is made out of some 3/4 inch diameter solid aluminum that I had on hand. All other components are stainless steel. I formed this out of some LL low density polyethylene I had. Again, it's easy to form. I just heat formed this using a shape that I created out of wood to mold onto. We'll get into that. I'll get into all those details later on. This is this receiver back here is high density polyethylene plastic I laid around. The rest of the Johnny Compost system, there's an air intake which comes off of this cap, which is PVC, and an elbow. That's not part of Johnny Compost, but the hose that's attached to it is Johnny Compost. And following that hose, it's over here on the left side, going into this space behind the toilet. And I would have loved to put it over here on the right hand side of the head because there's all that extra space as I mentioned earlier down there, but there is an obstruction. which is basically a housing for water tubes coming from the water tank. Anyway, that Johnny Compost hose comes up through this shelf, is connected to this fan, which pulls air up through the head, and then ventilates it out through this connection here. So the Johnny Compost is the black hose. It makes a loop up and connects to this white tube. And this white tube is connected to a 3/4 inch vent through the hull. And that's basically repurposing a vent location that was set aside for a vent for a water tank. But I widened the hole loose to 3/4 inch, and we'll show that later in the video, the connection to the outside. That loop is made such that if there is a wave that we take on that side of the boat and water gets into the system, it'll run back out versus going down into the toilet or composting head. And right now it's all this, the fan is being run by this AC/DC converter because I don't have my batteries hooked up yet. All right, so let's get into some of the details on making this composting head. So as you can see here, I have a contoured surface that conforms with the hull shape. It's there's nothing square. This is a curve. This is relatively straightforward line here. And what I did was I took a cut out of what my bucket base profile will be, about 11 inches in diameter, and I folded it right into the contour here of the boat, and then I took some tape, and I've taped the incline here, which is I think around 15 degrees, and then I took some square measurements off of where I expect to put the center of the bucket. And so I'll take this back to the shop, and this will take my angle for my trial bucket, which I'll cut. So what I have here is a trial bucket. Don't be alarmed, this is not a used bucket, at least not for human waste. This is asphalt. Anyway, this will be a space for my urine receptacle right here. And I took that shape, that profile that I showed you on the last clip, and cut using that cardboard form. I cut a bevel to the bucket, which you can see here, and here's the weld here. So this is HDPE plastic, and this is HDPE plastic, and using a Harbor Freight welder, I had a piece of scrap HDPE that I use as the welding rod or joint maker right here. Here is the final version of the LLPE 5-gallon bucket I modified from US Plastics. I trimmed off the top 2 to 3 inches of the bucket, which has a 1/4 inch wall thickness. And this was easier to work with for mounting hardware and for welding than the 1/8 inch wall that you find on a standard bucket. It's also wider in diameter than the regular 5-gallon bucket, so I gained more volume for solids. Also shown here is what I welded on the bucket. It's 1/2 inch HDPE ears onto which latches will be mounted, and a mounting plate at the base. The Harbor Freight welder I used is also shown. I used my mill to cut concave surfaces in the HDPE ears to match the curvature of the bucket. If you don't have a mill, you could do about as well with a rasp and a file. To locate holes to be drilled for the main axis of the mixer or agitator, I used a square and slid it over to the center line of the bucket and into position parallel to the orientation of the bevel cutout, which in turn matches the orientation of the boat's hull. The level got me square vertically. Making the agitator was next. I have several 3/4 inch aluminum rods laying around, so I went with that, but using stainless would have been best. but I'm not equipped to weld that anyway. Here you see my jig for welding the agitator together with 4.5-inch fingers. When assembled, the agitator will trace out a circle when rotated that will come within 1/2 inch of the bucket walls or bottom. I used a Hobart welder and argon shielding gas, but I had a lot of trouble getting the shield glass to work around the curved surfaces. I should have paid more attention to Jody welding tips and tricks on the YouTube. Here I'm checking the fit of the hub to one of the handles that will be welded to it to make the handle for the agitator. The inside of the hub is 1/2 inch. A set screw will hold the handle to the agitator. So I threaded my L-shaped bracket so I could put in these thumb screws, and it makes for a pretty rigid assembly, except you can see it does rock. So I'm going to use cardboard and start with a trial run coming out to some supports here, and this will serve as both a support for the bucket and also for the toilet seat. The next task is making the receiver that will be bolted to the wall in the head and will hold the bucket in place. I used paper to start the process by making a template to cut cardboard pieces to plan the construction. After a couple versions with the cardboard pieces, I then cut 1/2 inch HDPE plastic pieces from the cardboard templates. I then screwed those pieces together and welded them together for strength and to seal joints from harboring mold and bacteria. I smoothed all cut edges with a rasp, filed them, and then finished them off with sandpaper. I had to cut notches in the bucket here to accommodate these guys, and otherwise it was pretty straightforward. I also made a gasket for the lid to keep things airtight as much as I could. This is pretty much a small gap between those two surfaces. I'm not sure if I'm going to use another gasket for that. Maybe a little bit of air coming in is a good thing, but we'll find out through use how that goes. I traced the cross-section of the plastic soap bottle on paper, then I cut plywood to that shape. I pressed the pre-warmed LLDPE to the wood using wood screws, then added heat to get the plastic to memorize that shape. Okay, I've taken a brick of coconut coir and added almost a gallon of water to rehydrate, I should say, the coconut husk. And I'm going to pour this, see how much I need. I'm having a strong suspicion I don't need the whole brick of coconut that I had originally. But we'll see how it goes here. Yeah, I have my agitator is just about covered. So I think I'm gonna see how this goes. Well, that's about it for this video. I wanted to say a couple more things in closing. And that's regarding this lower latch down here, actually missing latch. So I built this ear with the intention of having an upper and lower latch on both sides of the bucket, and that would facilitate the bucket just merely sliding in. I wouldn't have to do the angle that I have to do at this point to get over the brackets, L brackets out in the forward side of the bucket to get the bucket into place for the receiver. I initially wanted to go with this extra bit of security. I may go back to just having the latches, which again would make it really simple to get this bucket in place. The other thing I want to mention is construction. So we decided to go with plastic here. One could go with wood, of course sealed and coated with epoxy or varnish. But wood for the ears and wood for the receiver. That way you avoid plastic welding. As far as the agitator goes, one could go with square tubing and maybe a round insert where the rotation's occurring through the bucket wall. And same thing for the handle, square tubing here too. All that stuff could be bolted together, and you would avoid the machining of the aluminum and welding. But I wanted to pick up practice for both the plastic and the aluminum. That's why I went that route. Now, for the compost system, actually the Johnny compost system I liked, and that's why I chose it here. The thing I was aggravated with is actually on me. I didn't do enough shopping because there are a number of components on here that comes with the system, I should say, that I did not use on here. That includes all the vinyl tubing because it was too stiff for my application. Most of the vent tubing that goes out to ventilate the toilet because I have a short run. I didn't use the vent cap that comes with the system because it's designed, the toilets, Johnny Compost system's designed for a vertical rise. In my case, I had an existing vent, so I just went out the hole that way. So those components I did not use and I paid for. So it's on me for not doing better shopping. I want to say a couple things about compost here too. You should stir this about once a day or once per use. And the frequency that you have to change the contents of the bucket, from what I've read and seen, is of course depends upon how often it's used. But for a couple of it's about 2 weeks. And I want to say a couple more advantages here. Note a couple more advantages about composting, and that's that I'm not worried on a cold day like this in Colorado. I'm not worried about stuff freezing. That would be the bowl, the tubing, tank on a traditional system. I'd have to winterize it. But in this case, I'll just wait for a warmer day if it gets stiff. The other advantage is that the most soiled, and I hate using that word in this context, I should say the grossest toilet paper you can leave in here. And you don't want to go to excess in the amount of toilet paper you dump in here, because that'll just hasten the time that you have to replace the contents here or dump them out. But that's another advantage. Just throw the nastiest toilet paper in here and forget it. The other thing I want to say is thanks for joining me on this venture. And I hope you enjoyed it and got something out of it. If you appreciated the video, please leave a like. And if you want to leave comments, that's great too. Thanks again for joining me. We'll see you next time. And hopefully, we've got a couple more days left of warmth here in November. We'll get out the Old Day Widgeon for a brief sale. Thanks again. We'll see you next time.